All right, so lesson 4 is inverse. And of course, sticking with my green unit. Okay, so the main concept of inverse functions is all you're doing is switching x and y and solving for y. So, inverse functions undo each other, okay? So, some notation that might look familiar to you is, okay, is f, okay? So, we're still going to use this type of notation, okay? Here is our original function, okay? Original function, and this would be our inverse function. Okay, so we have f of x, which is our original, and then our new notation, which we should be familiar with, okay, that we will be using, f to the negative first means inverse. Okay, with that -1, that means inverse. Okay. Okay, so as we always know, replace f of x with y. Okay, we're switching all the x's and the y's. We solve for y. These are your steps. And then rewrite y as f to the negative first x. So that means the inverse. Okay? Right, so this is important. You're switching all the x and y's. Okay? You're switching all the x and y's. So what this looks like in an equation, okay? You are given f of x equals negative 6x plus 2. So our first step is rewrite it. Y equals negative 6x plus 2. Okay. When you guys get going, you will already pass this step, okay, because you know f of x means y. So now, in step number 2, we're switching the x and y. So it's x equals negative 6y plus 2. Okay, so we're switching the x and y. Now we are going to solve for y. What do we do first? So we have x equals negative 6y plus 2. How do I solve for y? What's my first step? Ever? Good. Minus 2. So we have x minus 2 equals negative 6y. So again, solving for y. What's next? Yeah. Divide by negative 6. Okay, again, solving for y. So right now, we have x minus 2 is y. That's what we solved for. But we want to rewrite it in function inverse notation. So f of to the negative first, x equals x minus 2 over negative 6. This would be your fourth step by rewriting. Okay? So if you were to see something like this, okay, x minus 2 over negative 6, you could also rewrite it, and pay attention, because this is 1 in front. You could also rewrite it, because you will see this, negative 1/6 x. And what's negative 2 divided by negative 6? What does that reduce to? Yeah, Emily. Positive 1/3. So these two mean the same thing. Okay, so to find the inverse, you switch x and y and solve for y. Now to prove that they're inverses of one another, okay, to prove that they're inverses of one another, you will compose both functions. And when you compose both functions, you should get an answer of x if they are inverses of one another. Okay, so what that means, I'm just going to extend the page. Okay, we're going to prove, or to see if this works, f of g of x. So what does that mean? What do we have to do? Yeah, right. Okay, we have g of x. Plug it into here. Okay, so we're going to take the g of x function and substitute it into the x of the f function. So we have this. Now, does anyone know when you square square root, what happens? It cancels out. So we have, once we cancel out, x minus 5 plus 5. What are we left with? X. So are these two functions inverses of one another? Yes. So by doing this, both x squared plus 5 and the square root of x minus 5 are inverses. Okay. Yep. No, but you will see this at some point, so I want you to make sure you know both notations. You don't have to. But if you see it, you know where it comes from. Okay? So we are going to try some. We're going to try number 1 and number 2 together, actually all 4. Okay? Just flip the page. For the functions below, determine the inverse function. So in this column, okay, we are just finding the inverse. So in the end, we're looking for the inverse of x, right? So what is our first step in number 1? Luce? Good. So we have y equals 3x plus 5. Then we have x equals 3y plus 5. Now what? Yeah. Solve. What do we do first? Good. So we have x minus 5. Okay. Then what do we do? Yeah. Divide by 3. So our inverse you could also write it 1/3 x minus 5/3 as well. All right. Any questions so far? So in order to find the inverse, what is the first thing you have to do? Yeah. Change, flip x and y. Good. Okay, number 2. Same thing. Okay, we're switching x and y. What do we do first? Oops. X plus 3. Okay, now what? Yeah, Everett. Yep. That is our inverse. Try number 3 on your own. Okay, for number 3, what do we get? What's our inverse? Tyler, what's our first step? It's supposed to be f of x there. Right? We're supposed to have f of x. Okay. Zach, what comes after that? Before that. Before that. Yeah. We did switch the x and y here. Yeah. We have to square both sides. So we have x squared equals y plus 4. Then what? Yeah. Okay. So our inverse okay, and please remember the notation. Okay, f to the negative first. All right, it could be also g of x, h of x, or even if it's y. If it stays as y, then you would do y to the negative first too. Okay, so whatever it gives you to start, you always want to use that notation and tack on a negative 1. Okay, so number 4, we're going to switch x and y. Okay, what would be our next step after we switch x and y? Emily. Add 4. Okay, now what? Yeah, Everett. Multiply both sides by 3. Good. Okay, now what? So right now we have 3 times x plus 4 equals y. What would be our last step? Let's distribute 3x plus 12 equals the inverse. Okay. Any questions on 1 through 4? Okay. Look at number 7. Okay. The next column, and we're only going to do 1 or 2 from the next column because some of them can be a little difficult to see. We're going to try them. So number 7, we need to prove that these two are inverses, or to see that they're inverses. So in order to do that, we have to do f of g of x to see if it equals x. That's what we're finding out. Okay? So, take the g of x function, plug it into the x of the f function. Cube root of x minus 5 cubed plus 5. What happens there? Okay. It cancels. Take cubing a cube root, cancels it, so I have x minus 5 plus 5. What do I end up with? Yeah. X. So these are inverses. Try number 8. So to see if they're inverses of one another, f of g of x, g of x function, plug it in, cube root 2x cubed over 2. What happens when you cube a cube root? Cancel, so you're left with 2x divided by 2. What's left? X. So they are inverses of one another. Good. Okay. Well, I believe you guys can handle, since 7 and 8 were really good, and what you did. Try number 6. Okay. Proving that they're inverses. Yeah. Yes. You may. Okay, for 6, did we end up getting x? For 6. Good. Awesome. Okay. And F. Okay, for those of you that completed number 5, should equal x, what you do is take negative 2x plus 6 over 7, plug it into the x of the f function, and what I did is, since it's both fractions, distribute the negative 7 to the top to get 14x minus 42, and 2 times 7 is 14. Both of those are divisible by 14, so that's why we get x minus 3, and then minus 3 on the outside. We should have, what, does that work? Does that equal 3? I missed a plus sign somewhere. Oops, I wrote it wrong. Hold on 1 second. Do you guys see a mistake? Did I wrote? Yeah. Anybody? Mia? Right. So, look at the math. Is anything wrong? Do you see any signs wrong at all? Yeah. Why? If they were both negative, right, the whole thing would be positive. Yes. So even if you see negative 7/2, right, if you were to see negative 7/2, one of them has to be negative. If they were both negative, then it would be positive. Okay? So if you're looking at it, we have negative 2x plus 6 over 7, and this is negative as well. So we pretty much did the top, right? So when we distribute, we have positive 14, negative 42, and this ends up being positive 14. So should I get x here? What should it be? Yep. But the whole fraction is negative. I want you guys to think. Anytime you're writing, so if I have negative 2x plus 6 over 7, this is the same thing as 6 sevenths. Okay, so here, looking at it, okay, only we have the negative 2 there, right? And it's positive 6. So when we get that, if this was a negative here, right? If this was a negative, would that end up being positive? Yeah. So in this case, are they inverses of one another? No, they're not, because you're left with x minus 6. Okay, I wanted you to get, this was a tricky one because of the negatives and the fractions and stuff. So anytime you see, when you're going through this, and you have something left over besides x, they're not inverses of one another. Okay? So I'm glad there was one on here that you were able to see, because it doesn't work all the time. Don't assume that x squared, and square root of x are always inverses of each other. Okay? Or the cube root of x and x cubed are inverses of one another. Or 2/7 x and 7/2 x are inverses of one another. Okay? So it's always good to check. All right? There's one more thing I want you to add somewhere. Okay? If I gave you a set of ordered pairs, So if I was to give you a set of ordered pairs like this, no equation, and you could probably fit it in this little spot at the bottom or here, just as another example to refer back to. If you were given a set of ordered pairs, okay, if you were given a set of ordered pairs, what would the inverse be? If you were given a set of ordered pairs, what would the inverse be? Anthony. Great. Good. Did the signs change at all? No. All you're doing is switching x and y. So the inverse of a set of ordered pairs, 2, -3, 1, -1, 4, 0, and 7, 6. So all you're doing here is switching x and y. Signs stay the same. Signs stay the same. All we're doing is switching x and y. Okay? All we're doing is switching x and y. All right? Questions? Yep. Okay. All right, we're going to do some practice. Okay? We're going to do some practice, 1.4 practice. With these charts, I want you to cross out the last 2 boxes of each. 4 boxes, I should say. Last 2 rows. Okay? You're using the function. Okay? I'll give you some points to use. X values. Okay? So you're using the given x values. You have function A over here and function B. Okay? You're first going to evaluate like f of -2. Get all your y's. Then the inverse is just doing what from this first chart? What do we do? Luce? Switching x and y's. Once you find the set of ordered pairs, in the next chart, you're just flipping them. Okay? So go ahead and begin the practice. We'll have all of 1.4. Okay? So we have time to get started and ask questions.